Hello, everyone, wherever you may be logging in from, and welcome to Live Academy, the virtual design learning platform by MEAL Middle East Architecture Lab. My name is Riyad Jokka. I'm logging in from Dubai, and I'll be the moderator for these online sessions. Semester 1 starts today and will continue over the next 4 weeks. Every week, we will bring on board an emerging architect whose work we respect and admire and love to give a lecture about their projects under the theme entitled that they choose. Following every lecture, there will be 2 classes by experts on a certain software that is widely used by architects working in computational design. So if you haven't already, please sign up to as many lectures and classes as you can. Our aim is to use this time of uncertainty and isolation to connect people and to spread knowledge. I'm very excited to start semester 1 with an incredible speaker. Arthur Mamou-Mani has been on my radar for a while now, and I've been very happy to see his project scale in size and complexity. And the most notable of his projects, as we all know, is the temporary structures for Burning Man, which has attracted a lot of attention on social media and other mediums. So I'm very much looking forward to see what happens at the back end of the process in Arthur's lecture today. Arthur Mamou-Mani is a French architect and director of the award-winning practice, Mamou-Mani Architects, which specializes in new kind of digitally designed and fabricated architecture. He is a lecturer at the University of Westminster and owns a digital fabrication laboratory called the FabPub, which allows people to experiment with large 3D printers and laser cutters. Personally, I've found the humble and down-to-earth approach that Arthur takes to life and work to be a refreshing breath of air in a profession daunted by ego. Today, I hope to see the backstories of his amazing projects and to meet the person in person. Arthur gave numerous talks, including the TEDx conference in the US, and has been featured on the cover of Financial Times, the New York Times, and Forbes magazine. Prior to founding Mamou-Mani Architects in 2011, he worked with Atelier Jean Nouvel and Zaha Hadid Architects. So everyone, please join me in welcoming Arthur Mamou-Mani.
Yeah. Well, thank you so much, Riyad, and it's such an honor to speak to so many people, and it's indeed very humbling because I can't really see all of you, but I hope you can hear me, and I hope it will make sense. And really, it's not about for me to show all my projects; it's more to explain what's the process and what you guys can learn from it, and you know, the journey, basically explaining the journey of setting up a practice, of starting. You know, something, you know, from at school. I actually will start with my diploma project. I graduated in the same school as Riyad, the AA. And so I just want to show you where this came from and where it's going now is obviously, you know, we're out of a world crisis and I think we all have to learn a lot from it. I've learned a lot. I've changed my practice, you know, since. And so I just want to explain what happened and how I adapted. And for a while, I was kind of looking at circular economy and how can the idea of digital craftsmanship and all the things we've learned with parametric design and so on can impact the architectural world, really. So I call this circular thinking and growing buildings as ecosystem, and I'll explain that. I think Riyad will agree very much so if I said that we all have ecosystem rather than practices. And so I have an office, eponymous office, I guess, with my name, but I also have a fab lab where other people can realize their design. So trying to empower other people to do what we can do, but also what they can think of with this inspiration. But of course, I have other stuff, you know, teaching at Westminster, writing some plugins for Grasshopper and teaching with Simply Rhino, some workshops for people to learn Grasshopper and so on. And so this is our office, and I'm very much missing it, although we're all online, like Riyad. We are a small team of 10, and we make stuff. So this is, you know, by Studio Narrow, they came to the office and they kind of decided to stage us in a way that represents what we do, but you can see a lot of our different projects coming together, and always projects are, you know, I wouldn't say making babies, but kinda like each project inform each other. And so you can see a lot of projects communicate with each other. The whole knowledge of one project will kind of go towards another one. And so we very much work together as a team, but also with the machines that we have. So this is a giant 3D printer. that helps us do interior furniture, featured pieces like this desk that we did, or it also helps us think how it can scale. Riyad talked about scaling and how our project scaled over time. I never quite kind of thought our projects to be, you know, focused on the small or on the big, or to me, what matters is the approach. And then after that, an approach can scale or not. But really, we were lucky. I think we were part of a generation that played with 3D printers and assembled 3D printers. So we got to understand machines and the sort of hardware and software that are behind it, and how actually it's pretty accessible. And so when it comes to large building, I always wondered what it would be if instead of doing a big project and then sort of live it up to the economy to fill it up or to empty it, what if a building could be assembled and disassembled? And so it's this idea that maybe we need to rethink buildings like the way nature works. You know, maybe you're walking in a forest and a plant hasn't survived because of lack of sun. Well, it's okay. Things can die, things can be born somewhere else. And if we don't have that flexibility, then we're just doing things that are not very living, if you will. So this was for the wired show at the Tate Modern. It's called the Polybot, a project we did with Arup. And of course, we went to Burning Man many times, which is a sort of, I don't want to call it a festival, it's more of an event, a utopian city where people come and then build things and interact with the community under 10 principles, and then sort of burn or demolish thing, or and then leave no trace. So I'll come back to that, but this has really shaped the way I practice. These are some examples that I'll show across that lecture, which is about an hour. So I hope you'll bear with me and come on the journey with me. I've just before the COVID crisis, I was in Saudi Arabia working with Chris Precht on a project that we 3D printed out of sand using a sort of octotruss. And so we try and work with local materials so that our approach to technology is really to help the planet. So it's not technology for its own sake, but rather technology to help or to understand or to educate, or it always has a purpose that is beyond the technology itself. So I'll show you how I started with small projects that are more in the world of visual experiential marketing. I also kind of switched to weird things like 3D printing food for one of the ex-chef of El Bulli, who asked us to come up with a restaurant that is 3D printed and with the G code informing the food. And I also do more, let's say, quote unquote, conventional projects that we try and build ourselves. So this was the render and the real thing. And so we built that staircase in the FabPub, which is the workshop we also used for our own project. And so it's very much kind of confusing our client. Are we the contractor? Are we the designers? And I try to do bespoke things like this where actually we're on the edge, because I really think there has been a disconnection between the designer and the builders. And the approach that we have was always kind of akin to the builders of cathedrals, or at least that's what I want to aim for, where there was a sense of collective co-creation and something that was informed by the builders, by the metal workers, by the timber carpenters. And so that's how I see the real benefit of parametric design, that it brings people together, it brings different skills together, and ultimately Galaxia was a sort of proof of concept, if you will. And so parametric design is an ecosystem of tools, of people, of hobbyists, of people that want to share, of people that have an open mind. And so in that sense, I think we probably will connect with this idea that we're all here to help each other towards making a better world. And it's in that spirit that I created FabPub, so that other people can come and rent machines per the hour. So we wouldn't be the technicians in between the machines and the people, we would be the teachers to allow people to use machines. And so this has grown from 1 containers to 5. It's in Hackney Road in London, reopening soon. and I don't know if you guys are familiar with the work we do with the University of Westminster, with Toby Burgess, but we try and share our techniques on wewanttolearn.net. And we always encourage our students to think like entrepreneurs. And so in that sense, we tell them not to wait for clients, but we tell them to kind of find clients through the platforms like Kickstarter or Crowdcube. And proud to say we have a student who raised $100,000 on Dragon's Den recently. I was very happy about that. because I think it's up to us really to redefine the economy, to redefine the role of an architect, and not necessarily be a sort of passive profession that waits for clients, that waits for money. We can redefine what it is to be an architect. And I find this really empowering and important for students. So I started at the AA. I had my diploma in 2008, right before the world crisis. So I'm kind of used to it now. And it's actually in these moments that you see that you can really change the world, because you have people enter confused in a new era, and you kind of realize that people are maybe more open towards these new possibilities. People don't necessarily want to go back into the world that they were at. So this was the ancestor of Grasshopper. Grasshopper is the software we now use for parametric design, and I'll pass on the details of this, but the idea was to link parametric design with environmental analysis. And so it was creating a facade for, in the Communist Party headquartered by Oscar Niemeyer, in order to see when light could come in, when it's cold, and to prevent light from coming in when it's hot. So all these drawings I'm showing you, because I know some of you will be in the Live Academy, I just want to show you that parametric design is not just a tool, it's also a way to represent, it's a way to understand buildings as systems. And so in that sense, that building is not quite a shape, although Oscar Niemeyer was one to draw something on a sketchbook and then sort of realize it. This building is more of a system in that sense. I'm very much influenced by my parents. Here they are on the right. They were hippies, obviously, from very different cultures and backgrounds. And in that sense, they wrote a book together in which they were saying that we need to go beyond profit. We need to think how to reconciliate Woodstock and Wall Street. And so it's something that really resonated in my mind, and very much so when I graduated was when Lehman Brothers collapsed, and I was just wondering what it means to be an architect if we're really at the bottom of the chain of operations, really. And so I started kind of doing my office with the thought of creating a fab lab, and then realized that there were all these opportunities, including this one. This was the RIBA window display project, in which the Royal Institute of British Architects pairs you up with retailers. And so the retailers that chose me, because we chose them as much as they chose us, was Karen Millen. And I went to Karen Millen with this idea of using a fabric and folding it at specific location, reproducing what's called a smoking pattern. And then to kind of tell a bigger story, because obviously it's a very big shopping window. And so in the spirit of English gardens, we made this giant English garden that told different stories, whether it was the reveal, the flower. The idea of creating flowers and so on and gardens didn't come from the start. It came through exploring this material. It came from playing with the system. I think that's something that's kind of important to say, is when you do parametric design, you don't quite know what you're going to get. And often, you're told that you need to think of a concept and you need to have a vision, but it's not that easy, because the vision is strongly influenced by your experimentation. And in that sense, you're more like a gardener, more like a listener. You're playing with your parameters, you're learning. And as you're learning, you're just observing key moments that you think are really interesting or might fit a wider story that you have. And so at first, when I was just by myself really in my room, and then I had access to a laser that I could rent from somewhere else. And then so I started experimenting with origamis, with folding, with curved folding, and showing it to clients. So I had a pool, I started developing a pool of clients that I would just send exciting things to. I didn't quite know what it was. I didn't know quite what I'd do with it, but I was just excited. So I just want to share the excitement with the client. Because I think, as long as much as people think business is like a kind of conflictual relationship, you need to impose contracts and so on, it's also a relationship between someone who believes in art, believes in things that are exciting, and someone who wants to make it happen, right? And so this is, for example, a typical drawings that I would do when I do systems, right? This is called a matrix. And so you put your parameters and then you observe the differences. So you don't show one drawing, you show a matrix. I think that's something that allowed the client to feel part of the creative process. These were variations. After we did the one project, Karen Millen rehired us 5 times. And then I was very lucky to have Burohappold, the engineers, being right next to Karen Millen and saying, "Oh, Arthur, we saw this thing that you did down the road. Could we have the same thing in wood?" Something like that. I mean, obviously it was longer discussion, but it was something like that. And of course, I thought it was an interesting challenge, and I kind of looked online and saw what was possible, and I thought, yeah, surely there's a way to bend wood in a strange way. And this is where this lattice hinge came by, and it was a sort of open source technique on the Instructable by a guy called Aaron Potterfield. And I was really, really excited by it, so I downloaded it, I put it in Grasshopper, played around with the parameters of a surface. I'm sure you'll see this during your practice. And then by playing with the U and V's, you can kind of get compression and expansion of nerves and so on. I'll pass you on the very details of it, but what happens is the more dense the area, the more curvature you get. The less dense, the less curvature. And so you can play with this. And instead of applying a pattern on a surface like I did for my diploma, the pattern made the surface. And I think that was a kind of aha moment, like a moment where you're like, oh, isn't it better when the pattern creates the surface, when the system creates the surface rather than imposing a texture on something? Or can there be a conversation? And so these are the prototypes we did. We kind of stopped doing drawings by this stage, and we showed Burohappold all these prototypes. And I think they really appreciated playing with us. Because when you do matrices, you play with the client, you play with the material. And this is a matrix model. It's not quite a drawing, but a matrix model. And really, I mean, what contractor will kind of take a project like this? So we ended up making it. We ended up learning LEDs, connections, and so on, adding insulation and so on. We had to install it ourselves. So we became the maker of that project. I wouldn't say against our will, but it's just kind of, what sort of contractor will say yes to that? You know, am I going to trust the contractor not to break anything? Like, and also I could iterate. So we finished the first version and the client's like, you know, it needs some openings. So we did some openings and so on. So we had total control over the production of this project. And so in that sense, we could kind of really work on, say, 3 modules that would kind of play with, say, the AC units, the projector, the very pragmatic things you find on the site. And so it really helped us create a sort of zone that people could appreciate. And it's still there after 5 years. So if you are in the Oxford streets around there, you know, I encourage you to see it. And what I didn't realize is we were developing products. We were developing things that other clients could think. And so we had this visionary client who's like, oh, can I use it for my bed? And so we kind of switched it into a sort of bed stand, which was pretty amazing. Another lucky moment that happened when we did the Burohappold is that in Remble next door, they were like, Virgin Galactic needs a hotel for their astronaut going to space. And so I, you know, obviously I received this phone call and we had a weekend to come up with a concept. And I remembered when I learned computer science at school, we learned it through a turtle. It was called Logo. I don't know if any of you kind of played with that turtle. It's still available actually on Python. You give an indication, go right, go left, and so on. And I just remember staying for hours realizing that the computer can generate things so that I don't need to kind of draw something. I can just draw a set of instructions and then see what happens. And all these geometries really looked like kind of natural shapes. And I got really excited. So when I heard Galaxy or Virgin Galactic, I thought, let's do this and let's link this with the environment. And so in that sense, this was a really kind of nice transition from sort of the usual grasshopper to what we call recursion, in which you know, the start becomes the end and the end becomes the start, and you create these growing structures. We played with the landscape to create thermal mass, and we created a zone in the middle that people can enjoy as a sort of collective gathering. And so we had a sort of environmental approach to that. It also looked really nice when you kind of came up with your spaceship to see the galaxies down there after seeing the galaxies up there. And, you know, it's something that it sort of stayed in my mind as I was going to Burning Man. And so around that era, I was sort of playing with the very first 3D printers. This is called the RepRap. I don't know if any of you assembled a RepRap, but I remember playing with a RepRap, and a friend of mine, Adam Holloway, he came and he said, I did a whole grasshopper to create G-code. And at that time, I just learned how to do C#. And so we kind of paired up forces to create this. And so I thought what was exciting at the time, I mean, this was, I don't know, like 5, 6 years ago or something. We just kind of thought, well, so why do we take geometries, then slice them, then put them, in the machine after going through a third-party software that slices the object? We thought it would be better to just kind of skip that and do polylines on Grasshopper and then export that straight to the printer. And if you did that, you could control the speeds, you could vary the parameters of the 3D printer, just like we varied the parameters of forms. So we could create patterns that are really, how can I say, within the process itself of talking to the machines and the G codes. And so we started doing that, and then that allowed me to do many projects and many, it was open source and free. And the beautiful thing is when you start doing this, people give. So you give and people give, and someone sent us a printer. Oh yeah, and then, this was a kind of nice opportunity to engage with the kids, because the kids were going crazy. They saw these machines and and I always thought it was nice to have a sort of educational aspect to your project, because you inspire people, so people want to do it. So why not help them do it, And one thing I realized with time is the material we used is called PLA, polylactic acid. And that material is something that is compostable. It's made from fermented sugar. And so it doesn't quite end up in the ocean if you don't want it to. It can actually just go back to the earth through a composting facility. And so one of the projects that we worked on, COS, which I'll show now on the last Milan Design Week, was strongly inspired by these two ideas that maybe we could combine the cradle-to-cradle approach, the idea that things can go back to nature and come from nature. So together with the makers movement, which is the idea that you can distribute fabrication, so that you can send a file to someone, I don't know, in Italy or in China, and if they have the printer, they can do it locally, which is what we try and do for many of our projects, including this one, which was last April. A nice project, really, was well received, because I think people started understanding the potential of that technology in relation to sustainability. So no longer in terms of, it's cool, it's 3D printed, but more like, so actually when you build modular structures with local fab labs, you can actually create a structure without transporting stuff. You can actually compost the whole thing. Or in this case, we made it modular. We thought we were going to compost it, but actually people are like, can I have one of the modules? Can I have one of the modules? And because they were small, they were about 1 meter by 1 meter, people just took them. And so we gifted them to everyone. And so people ended up having them in their garden, growing tomatoes on them, or you name it. We have a table in the office. People were very creative. And again, that was a sort of way to encourage people to kind of deconstruct this whole thing and take it with them. So it was a really important step for me, which is how to think of a project that can dissolve itself through gifting, say. And in that sense, this project was a bit of a kind of rethinking of what I thought could happen to projects. The other nice thing is it was so porous because we maximized tensions. So to give you a sense of the trusses here, they're about 3 millimeters in diameter. And there's obviously millions of them, but in the way they are arranged is they take all the pressure on their long axis and therefore they're in tension. And by being in tension, that means that you need smaller sections than they were in compression. And so this orientation is something we tested with our engineers, but on the tool called Caramba, which is in Grasshopper. And so we had the same file, so we can iterate together. And then we printed it flat. It's weird because everyone wants to print in midair nowadays. But it's so much faster to print flat, obviously, because you don't need to dry it that much and so on and so forth. And for us, it wasn't about the coolest technology. It was about showing what can be done and what can be sustainable about it. And so we printed it flat and assembled it. And we had to send, we had 700 modules to build in 2 months. And so we calculated how fast we could go per module using Silkworm. And so you see the toolpath that we created, which is really how to accelerate and minimize materials with the engineer. So you see 3D printers on one side, engineers on the other side, fabricator locally. So a lot to think of. I say kind of a holistic project. Holistic because there's so many different aspects to the design. There's not like a design. There is a set of parameters influencing the growth of a design. And I think that's where I really enjoy this parametric design idea, is this idea that the parameters grow this thing. rather than from the top down. So I think it was the largest PLA structure ever built, which was pretty brilliant considering we didn't quite have the space inside. So this is our studio, this is on WhatsApp, the other Fab Labs, everyone is panicking because we're running out of space. But it was quite fun. I mean, and this is another one of those big 3D printing projects with Chris Presch. Chris is an amazing guy. I'm sure you'll get a chance to see his stuff. Extremely humble, is in the mountains, and we met together in a conference like this one actually, and we just clicked immediately because I think we have very aligned values of how to help the planet through new ideas. And so this was, you know, in Saudi Arabia. We both thought, well, should we work in Saudi Arabia? I mean, I've talked about bioplastic, using less oil. So what am I going to do there? And we both said, well, actually, if we can't innovate and show a different kind of way, then who will, right? People will just go there and continue the old way. And so we thought, well, why don't we just use the local material? Since it was used before, we could use sand, and we could 3D print with sand, and we can come up with a module that people can use for urban furnitures, for shelter, and so on. And so we came up with this idea of having this sort of tapering module. There's two types of module, the small, the large, and we printed them in yin-yang fashion. Obviously, having long conversation with the local fabricators because we couldn't make it, right? So in this time, we were not the contractor. There was a contractor, but because it's 3D printed, I mean, go and tell the contractor, yeah, go and lift this thing, but be careful of this member and that member, and so on and so forth. It's a very, very unique. These are sketches of Chris and I when we were on site together, and this is back from the contractor, and so back and forth. Continues back and forth too. And so, you know, who designs, right? I mean, is it the contractor? Is it his engineer? Is it the architects? I don't know. The truth is, I don't know that one could call one designer, right? I think we're all kind of designers together, collectively. And in this case, one of the main criteria of the design was this machine. It has a giant kind of sand machine in which we could do this sort of archaeology of printing these layers and layers. And you see this really, really thin things. These were dictated by the computer. We had a lattice, put the lattice in Caramba. The Caramba tells us the thicknesses for it not to break. And then we print it. And then we assemble it. About 160 kilos per module on these bases. We had about 58 modules. And so it created this really, really intricate, ethereal structure in which people kind of, they weren't quite sure what it was really. Is it an extension of the palm tree? Is it and so it was really interesting how people interacted with it. And so I wanted to kind of take you to another desert, really, another place where it was quite challenging. I think we've been okay. It's been half an hour, so just about enough to take you to the desert of Burning Man. So Burning Man is a special place, really. This is a city that is built in, really in a month, maybe, behind the scene, and then the artists arrive about a week before it all happens, and then we built the rest of the city, the art, which is why you have this shape. The shape of the sort of semicircle was to surround the art, for it to be a city around art rather than generating art. And so you see these principles. Well, these are the guiding principles of Burning Man, which I always thought, with my colleague Toby, was an interesting way to think of society, of teaching architecture. And that's why we did this at Westminster. We took our students to Burning Man and learned these values. They're important values, the one called radical self-reliance. There's this saying, tell me and I forget, teach me and I may remember, involve me and I will learn. When you're involved in something, when you're actually assembling the bolts, when you're actually seeing things fail in front of you, you're going to learn so much more than if you're kind of just sitting in a classroom, right? Like doing is learning for me. And that's why we always were keen for them to, apply for the grant, win the grant, spend the money, raise the funds as much as we can. And so this was really an experience of learning for everyone, including ourselves. We were learning. So that's why we want to learn. I can't claim that I knew it all. On the contrary, I was maybe the biggest learner, really. And so this is Larry Harvey, the founder of Burning Man, who said, instead of doing art about the state of society, we do art that creates society around it. And I find this really fascinating. The idea that everyone is an artist. I don't know if it's the same for you, but in France, you're categorized from a young age. You're the art kind, you're the math kind, you're the, you know, oh, this guy is not an artist, or he's not a creative, or this guy he's just an artist, you know. At Burning Man, everyone is the artist. You know, everyone creates this thing. Everyone is responsible. There's no hierarchy in that sense. This is a typical workshop. You have lots of workshop happening there. Identity alchemy. Let go of who you think you are. I think, you know, a lot of people need that. Not to have certainties. I mean, if you have certainty, you kind of let go of them very fast when you're there, because you're in a place that you probably would have never experienced. You're in the desert. You're in a sort of the constant sandstorm. You're cleaning these, you have to leave absolutely zero trace and go and find some pasta below the sand, really. Very, very hard. And so, and everyone has to organize themselves through what they call the shared struggle. And this idea of shared struggle, creating community, I find resonates a lot with the COVID situation, in which I find that because we all went through it together as a sort of species, the humans all went through that struggle, no matter where we came from. I believe it's kind of bringing us together. And this idea of living in one planet and having just really work together, no matter where we come from, I also find it from the writings of Buckminster Fuller. Buckminster Fuller wrote the operating manual for Spaceship Earth, and he says that the problem with humans is they tend to specialize. And when they specialize, they lose a sense of holisticness. And so if you lose that sense, then you're starting to lose the kind of greater view, you know, the view that people like Leonardo da Vinci would have, where they had a sort of boundless curiosity. They weren't artists or scientists, they were all of the above. And therefore they could innovate and they could come up with things that were revolutionary because they had an overview. And so I think this is it's a hard thing to maybe teach, but it's something that can be experienced when you're the makers of your project, when you are coming up with solutions and you're letting go of your initial ideas. I think that's what's hardest with architects. We have ideas, we have visions, and then everything has to fit within that, like a sort of shoehorn. Whereas when you're doing parametric design, you're like, damn it, what's that graft button? Whoa, amazing! And then that's when you sort of learn. You're like, that's actually better than my idea. Okay, let's do that. You know, and so that openness of spirit, I think, allows you to better yourself, to grow. And so that's what our students do. This is, for example, inspired by the geodesic domes, but it's a module that can be repeated. It's a very simple module, and through being reciprocal, it sort of stays together. And then we say, well, let's just grow it into what seemed to be a crazy structure. I mean, who's going to come up with stuff like that, right? Like, you've got to let go. And so that's how really the main lesson of Burning Man is a lesson in letting go. And so when we started doing things there with our students, we kind of simplified our how can I say, our coolness factor. We did simple things, but things that would resonate with people. And Burning Man chose these two projects from a pool of many, many projects, but they were a shipwreck and fractal cult. And we tested them with spaghettis with the engineers. One was made of scaffolding and one was made of laser cut wood. Obviously, lots of stuff to learn. We couldn't weld anything on site and so on, so we had to prefabricate most of it. But maybe more importantly, we had to come up with the whole village in which we had to live, right? This is where you live for a week or two, and you live as a community, so you're not quite the teachers, students, and so on. You're a group, and you're a group that's trying to build within these conditions. And so it kind of humbles you, I would say, because, you know, no matter how kind of knowledgeable you might be, when you're trying to install a scaffold at a crazy angle and the dust storm, or then people climbing everything, and you look at it and you're panicking and you're hoping that's going to stand up. It's a humbling process, you know. Another humbling experience before I take you to Galaxia is this one, and that's the tale of two projects from my students. One was the Infinity Tree, and one was the Bismuth Bivouac. And one was a complex kangaroo, reciprocal, you name it, everything that Grasshopper can do. And one was just 2x4s, offsetted slightly. 2x4 timber is the standard size of timber, of wood. And they both won. And so, you know, starting and looking at the file with the students, we're like, okay, it's more complex than we thought. The engineer says it has to be super thick. You know, there's a lot of forces in there. Everything is reciprocal, so you had to push things in. And so quickly realized this was going to be a very big challenge, especially when we started receiving the cut pieces that were no numbers on them. For some reason, the fabricator forgot to write the numbers. And so this is a professional carpenter. This is Toby, my co-tutor. These are the students here, and we're trying desperately to make sense of what ended up being a giant puzzle. There was no symmetry. Of course not, you know, because symmetry might not have been cool, right? But at the time, you know, we were proud of parametric design, but look at the difference, right? This is made of 2x4, standard off the shelf. There is a reason why this is off the shelf, right? Like, look at how neatly packaged this is, and look at the other one. And I mean, I say this in a kind of funny way, but you know, I'm to blame. Like, I'm the teacher, I should know these things, right? But then we had to like cut some kind of angled column on a spiral because we needed that sort of reinforcement. But by the time we built this, we had very little time to complete the puzzle. And so construction sequences was as important as the piece itself. The other ones were chilling. They were just kind of like, they're probably going to hate me for that, but they were just like kind of putting pieces offsetted one at a time with a screw. And so in that sense, you know, that project finalized on time. We were still struggling. We didn't finish it. We had this kind of cable around because the whole thing acted as a spring and therefore wanted to go down. It had a beauty of its own, but really what I thought is like, damn, like maybe we should listen to, you know, carpenters. Maybe we should listen to materials that are off the shelf. Maybe we should look and tweak off the shelf material. And this is really the baby between the two projects. It's called Tangential Dreams. It was for 2016's Burning Man. And it's a bit of a baby between the two projects because, yeah, as you can see, it's all made of off-the-shelf material. It's cut according to a matrix of numbers and with a circular saw, so no laser cutting involved. And we just orient it, we just order them. It's all rotationally symmetrical, and therefore, you know, you do one and then the rest sort of follows. And then it interacts with the people. And really the story is not about computers or technology. These were tangents, the tangents, which express the curvature of the slope of a curve, sorry. It was about the stories that people wrote on these tangents. So everyone could send me a dream, send us a dream, and then we would use a stencil and paint on it. And then people would answer, they had pens on site, and they would write on it. So they would write their dreams, they would write whatever they want. So every day this evolved with people's feelings and dreams. And so in that sense, I think Burning Man saw that there was potential to maybe use that approach to do a temple. And the temple is a special place because it's a sacred space within what is, you know, a really non-religious, secular place. Burning Man really is open to all backgrounds, all religions, and so on. And so the idea of a temple is a bit strange because really people see this as a party town, like the outsiders, right? But once you go there and you start seeing things like this, really, I mean, when you start realizing that's one message out of so many and the people around you are crying and they're really extremely emotional seeing these things, it makes you re-question what spirituality might mean. And I, you know, I completely cried. I completely, let's say, reconnected with that part of myself that was, you know, this kind of sad soul. You know, we all have sadness in us, and we don't really. We try to cover it. You know, we go through struggles in life. I went through depression. I had really big personal issues, and I sort of bury it. But when you see that other people are not okay, and I think it's really important to know that other people have the same struggle as you. And when you start realizing how deep that is, then you burst into tears and you reconnect with other people. And so that project was really expressing this idea of shared struggle. These lines, as you can see, were intersecting circles, creating a sort of lattice based on the Fibonacci sequence. These modules went from large perpendicular to very thin and long based on, I don't know if any of you know the spaghettification of black holes. You know, the closer you go to a black hole, the more the gravity, and therefore you become thin like a spaghetti. And so it's exactly the same here. The module starts almost like a kind of portal to human scale, and then Although they're like a physical gateway, they go into some kind of spiritual gateway, very thin and elongated, and you can't go there physically, but you go there spiritually, and then you see that, and then in the middle you have sort of teardrops that come back to anchor you to the ground. So this picture shows a lot of stuff. It's obviously, every time I see it, I see new things. You can see the sphere that was done by Bjarke Ingels and Jacob Lange here, called the Orb. And it was an interesting dialogue because Burning Man has so many big pieces of art and they all speak to each other, and you're with your bicycle and you stay in one of those benches here, and then you sort of slowly make your way in and realize what I realized when I first went to the temple. And by the time you reach the middle, then you just burst and you're just sitting down and you start thinking. And really, architecture in this case is not the form, it's a sort of sponge for people to place their emotions and to share this collectively. And to be one, really. It's not about a specific belief. It's about together realizing we're all going through tough things, really. The essence is that. And that we all want to let go of some stuff, right? And so that's what this was about. In the center, you had these tiers that were 3D printed with our machine that we sent there. And they were just sort of giant tiers going inside this volcano of an altar in which people would place things. And you can see the roughness of it all. You see the ratchet straps. I'm pointing your eye towards the imperfections of this project. I love ratchet straps, that's for sure. But I also just like the idea of softness and the fact that this project doesn't really have a hierarchy of structure. It's not like there's a main beam and then sub beams. It's all a lattice of 2x4, 4x4, and depending on the forces, we change the thicknesses and so on. But we don't let a main structure and decorate the main structure. Everything has a role in that structure, including the people that build it, really. So this is WASP, the world's advanced saving project. I love this company because they invited me one day to see their facility. They build giant Earth projects. And they want to save the world in an advanced way. Just that, I thought that was funny. But also they say, take your running shoes and we're going to see a city that will soon exist and we'll go back to Earth called Shambhala. So we all went there and we started meditating. And I just thought it was a fantastic thing to have companies that don't do this for the money, but they do this because they want to help and they believe in things. And I think we need more, and I think this is a beautiful thing. And when you meet them, you want to work with them. And so I invited them to Burning Man to build this with us, and they came. And and so this is the idea behind the build sequence. Remember how I said we struggle with the amount of time it took to build the infinity tree? Well, this is all rotationally symmetrical. You just build one of these bananas, and you become an expert in building bananas. And then you just rotationally symmetrical repeat them. And of course, there is different types of modules, and we had to sequence the whole thing. And one really nice thing is that because we had to fundraise, Burning Man gave us about $100,000, we had to fundraise $500,000 on top of that. We had to think of the cheapest materials there is. And so from the 2x4s and the 4x4s to screws and bolts, we try and use as little bolt as we could just by using an equation. So Format, our engineer, sent us the kilonewtons. When you're negative in kilonewton, you are in compression. When you're positive, you're in tension. They run the tools, let's say genetic algorithm, until you have a maximum of positive values. And then we run the equation and it tells us how many screws you need. And then we build accordingly and we order them, and our spreadsheets are done accordingly. It's built by students and people that are not necessarily trained, carpenters. So we thought, well, let's repeat the modules. Let's make triangles because, as you know, triangles are the strongest shape, said the Buckminster Fuller. And the triangles are made from one-dimensional members, those timber pieces, triangles, then a module. Module is folded, assembled with the ratchet strap and so on. So it's a really modular approach to architecture in which each module is volunteer-friendly. That was a very, very important thing, that any volunteers could read this. From the colors to the type of connection, the Simpson screws and so on, not using, kind of minimizing what's laser cut to the very essential, which was these plates. And that was very important because we would have struggled. To give you a sense, we had about 60 tons of wood, 40 tons of metal. And this was the prototypes we did full scale. So you see the double curvature of the triangles is slight, but still enough to become a problem of tolerance and so on. But everything using off-the-shelf stuff. So a 4x4 piece of timber, 4x4 cut in half, another 4x4, and a 2x4 being split in. I love this little picture because it says a lot about what we try to do. And this gives you a sense of the scale. We were a village, you know, I mentioned building cathedrals, like we had tents, we had a restaurant, we had a restaurant as in, you know, we were cooking, the team, but a zone to eat where really the social things, every night we stood up on our table, we said why we were doing this project together, what brought us there. We shared our struggle, we said what touched us about the idea of building a temple. And so we worked together in that sense. We knew why we were doing it, you see? And so this is the team, you know. The team builds this module on the floor and then folds it, almost like closing these gates to open other ones. And then the crane at the back would come and pick it up and then sort of ratchet strap, few screws, and it's brought together like this. And so, you know, we had a lot of people working on this, about 140 people on 22 days to build it. And so I can tell you it was a lot of coordination, a lot of planning with time in mind. So the assembly sequence was maybe even more important than the design itself. Like, what comes first? What comes second? What should come, you know, like third? How do you disassemble what? Where is that? That's, you know, the sort of spider crane, the sort of RVs, I just forgot their name, but everything mattered, like to know where they go. This was a SolidWorks model in which we had a central, so we couldn't drill a foundation. So we had a sort of bike wheel foundation that allowed the whole thing to stay tight, and not have to drill massive foundation. This saved us because of course we got it wrong and the last bananas didn't fit. And so therefore we just kind of, we kind of unscrewed the bike wheel, we moved the modules, we put it back and we put it in and we retightened. So flexibility was crucial. Like we couldn't have designed that where you have to remove everything in order to move something. It couldn't, it had to be as non-hierarchical as possible. And obviously dishwashing. Now, you know, it's kind of weird for an architect to talk about dishwashing, but really, Riyad talked about humility. And I think like, you know, even yesterday we talked about it with my wife, but I think people respect you more if you get your hands dirty. If you try your best, if you serve, if you give, you know, so we all dishwashed, every morning we had sessions together, seeing like what we could do to improve the group. There was a lot of discussions every day. We wrote the list of things to do on the truck, and we went through each operations, everything we would do day by day. It was beautiful in that sense, a real team effort, communal effort, which is one of the principles of Burning Man. So we all stayed trained, we all like a family. And I don't know if you read the book Homo Sapiens that said that civilization started by building temples. I think I can totally see how people came together around building things together, literally, you know, and I think that's something that really resonated with me, because when we did it and then we opened it, the building continued, right? This project wasn't about a final project. It was about a journey that started from, you know, the pre-build all the way to the burn and the recycling of the whole thing. This is when we opened it, people started placing a lot of emotional content in there, things like guns, like saying, you know, we missed the spaghetti of your wife, or this is my wedding. You know, yeah, I have a slide from my wedding in there, but my mom here with the megaphone kind of celebrating a happy moment. You know, we struggled so hard on that project that I wanted to also make it about us. You know, we built something together. She was here by my side, Sandy, from the day one. So I thought I would also celebrate something positive and something that meant something for me, which is another principle, radical, you know, self-expression. This was our self-expression and this was our love. You can't hear the music, but we're singing All You Need Is Love inside the temple before getting kicked out from it. Somehow someone came and said, this is a sacred space, how dare you're getting married and so on. But it was funny because I thanked the guy. I was like, well, thank you for protecting the sacredness of this place, you know. And we got out, and then we probably fell asleep or something. But here is, this another view of that temple with people quietly mourning and placing things there. You can't hear it, but a Native American came to bless the temple. And so it was a lot of things going on inside this project, and it was really an extension of the architecture, a continuation of the architecture, if any sense. So we fell asleep, very, very tired, let the whole place gorge itself with emotions, and then we burnt it. We burnt it in silence, about 70,000 people quietly sitting there, crying, knowing that whatever they placed in there would be gone in dust. And so there was a real sense of respect, and it was really part of this ritual. It looked like a crazy volcano, really, in this flat landscape. It was a really beautiful sight, and quite something to burn your own project, really. But it was, what I actually quite like is the day after we came, we made little piles with all the metal. We kind of recycled the 40 tons of metal, took care of the ashes. But I mean, of course, I didn't want to burn this. Of course, I wish someone kind of said, hey, we keep it, or. And so that's why I thought it would be good to think of another project that wasn't burned. And that's where Catharsis came, and I'll finish on that. I have about 5 minutes to talk about this project. Catharsis is based on a fractal called the disk of Poincaré, a French mathematician that came up with the idea of hyperbolic space, in which the edge is infinite. A really amazing guy came and asked me to do a camp in which we could talk about the future of cities, and it would be in the city of Black Rock City. And so I started kind of working on something that would be like an amphitheater, but an amphitheater made of amphitheaters, in which the center was relative to, we're not quite sure, right? Every space have its own center. Therefore, what do you look at? Where do you look? Where is the central stage? Where is the, And so I thought it would be really interesting that all of these spaces would be amphitheaters. And even inside, even on top, even through the galleries, performance would happen. All kinds of performance. The sort of creative equivalent of the mourning that happens in a temple. This would be a temple for creativity, a place where people would kind of place messages and art and perform and dance and you name it, up to people's creativity, a sponge in that sense of infinite creativity. And so this you're seeing the team here holding the model. It was made of modules, at least it would have been made of modules. It was for this summer. And it would be disassembled and reassembled at the Somerset House in what would have been this September, probably next September then. Everything is sort of shuffled around, but this gives a sense of these large spaces that welcome you into these kind of fine galleries in which people can place art. Now, I said how COVID completely changed my practice, and I just want to show you this. I've completely switched to another kind of reality, the virtual reality, and I started exploring the idea of kind of doing a parallel space, really, building all our projects in a separate space, the virtual reality space. This is on AltSpace, and everyone can access. If you have an Oculus Quest or Vive, you just download AltSpace, and you can come and meet me there. I'm quite often there. We're doing iterations of this project. We're going to officially opening it during Burning Man this summer in August, but come visit, add me, Mamou-Mani on AltSpace, and we can see when I'm online. We can do a selfie together. This is not my avatar, this is someone else's avatar. But what's really fun is I think there is some kind of parallel internet that's being built out there. They call it the metaverse. It's a place where, it's a space where you don't quite have to necessarily physically travel. I think we will re-question the idea of travel in the future. Well, simply because we didn't need to travel that much during COVID, and we realized, I'm a bit like Riyad, like I kind of wish it would continue a little bit because I really enjoyed being at home and having other kinds of travels, spiritual travels, reading books and going in VR and developing parallel worlds. And so that has completely changed our practice. And we're now building everything in VR. We're inviting our clients for site visits in VR. I can't tell you anything because obviously it's all like confidential projects and so on. But look forward to showing you how an architect can kind of adapt to this situation that is going to change the world, really. So that's it on my talk, and I'm just really thankful that you're still there. I hope. I don't know. I can't see the numbers, but thank you very much, everyone.
Thank you so much, Arthur, for this amazing presentation. I can see the numbers. We have about 146 attendees and a ton of questions.
Fantastic.
So thank you for finishing on time, and we'll get right into the questions. But before we do that, I'd like to just comment on your approach to work, and it's really evident in all the projects that you've shown us. What I find really interesting is how you have used the idea of crowdfunding to fund architectural ideas and architectural projects. And there are many different ways to run an architectural business, so to speak. But we are the generation that graduated into the recession. You know, you started your practice in 2011. I graduated from DA in 2011. I remember very clearly finding very hard to find a job when I graduated at that time. Obviously, you have had some challenges as well, starting a business back then. And now we're on the verge of a new recession with this COVID-19 situation. So what I find really inspiring is how you have managed to not sacrifice your ideas and the ingenuity of your innovation, but rather find new innovative ways to fund your projects. And kudos to that. I don't know if you have any comment on what I said.
No, thank you for that. I mean, I think when you're realizing that it's really hard to get a job, when you're realizing that you have ideas and that they're not quite happening out there, because I don't know if you remember, but we were taught 3D printing and robotics and so on, and there wasn't any company really doing that at the time, you know. I think maybe we were lucky, but also I think maybe both of us or more people, they realized that because there wasn't any practice, then the practice had to be invented, you know. And we were lucky that at that time, the 3D printers were in the affordable place where you could assemble them with the open source network. Right. So, you know, now is a great opportunity for people stuck at home to just order parts and learn about these tools that really at the end scale up. Like, you know, you did a giant pavilion in Dubai, Riyadh, like the tools are scaling up and are not so different from the small printers we were assembling on our desks or, you know.
Yeah.
Yeah.
So there are opportunities with the challenges presented our way. Yeah. Okay, so I'll leave more room for the hundreds of questions that I'm getting over here, and we'll start by host, please let Alawiya Ali onto the stage, and she's going to ask her question live. Now, just a note to all the audience: whoever raises their hand will get to become a panelist, and will ask on video their question to Arthur live. So I think Alawiya is going to be next. Let's see. So I think, okay, well, Jack Young, maybe, host. Can you promote Jack Young to panelist? Maybe people are shy to go live. But that was the whole point, guys. Okay, well, we may have a bit of a difficulty with this because I see people are going to panelists and then we're trying. So I'll start by asking some of the questions. Okay, so we have Jack Young. Jack, where are you joining us from?
Copenhagen.
Copenhagen, awesome. Well, welcome to Live Academy. What question do you have to ask to Arthur?
Hey, Arthur.
Hey.
Nice to see you.
Nice to see you. I think you're in that picture, aren't you?
Yes. One thing I wanted to ask you was, obviously when I was there and in sort of all your projects since, you mentioned getting your hands dirty, and I was amazed at how humble you were and how you kept your ego out of it. In everything that you were doing, it was really quite impressive. And you also have an incredible sort of sense of direction and purpose. And I was just wondering, you know, where does that come from if it's not your ego pushing it? You know, where does your sort of sense of identity come from?
Wow, that's very deep.
It's a loaded question.
Well, just to say that Jack is the guy on the right, a two-person on my right in that picture, and he did an amazing job, really. So same to you, really. I really appreciate you coming with us. I think you just how can I say? It's really hard to answer that. I guess maybe I learned that by listening, by allowing people to have a voice, you are going to allow more realities than your own. And when I was young, I mean, I was 19-year-old, and I had a lot of certainties, right? I was writing poems, and I thought I'd be a poet, and I was, I don't know, I thought I had a truth. I thought I had a truth in me, and then I went through depression. Somehow I did, I was stupid, and I guess I fell into a very bad mental state. And then I realized that my truth was nothing, that there's so many truths out there, that there's so many people that have struggles, that there are, going to kind of make me grow by allowing their reality to be another reality, by not imposing mine. And when I realized that, I completely shifted gear into a mode of accepting that whatever world I'm going to be part of, staying in this world, but staying in this world with other people telling me their own way. And I guess I thought that this would be a stronger reality. And I guess the drive came from accepting that. And so you're right, it's actually trying to dissolve yourself through others, but building a better self in that sense. And so, I think I always remember myself when I was too proud and too, and then ending up, with the depression and so that's I guess really shaped me in that sense. Yeah, sorry. Deep question, deep answer.
That was an amazing answer. Okay, Jack, thank you so much for participating. Again, whoever wants to ask a live question, we will let you as part of the panel, but I will jump back to one of the Q&A questions for the people that are too shy to go on camera. And the first one is from Mayur Mystery. I hope you pronounced that right. Mayur Mystery is asking, what gives color to those 3D printed materials? I think he's referring to the Saudi project.
So the Saudi project, the color came from, that's a good point, because the sand with the furan resin became really dark. And so we had to spray sand on top of the prints, which was a little bit paradoxical. I wish we could print directly with the right color, but we used it's like, I mean, that company was not meant to build architectural projects. They were meant to build molds for metal casting. And so those prints are made from the same sand as the mold for metal casting. And so they weren't meant to be pretty looking, And so we covered them with another layer of sand on top because otherwise it would look like a volcano. I mean, Chris and I liked the volcano color. Like we thought, let's do the whole thing, black and so on. But I think I kind of agreed that it was nice for it to look like sand. Maybe next one we do it in another color. I don't know.
Yeah, no, the finish is really amazing, actually. And as I told you in our previous conversation, I looked through the zine thread to see your reply on the technical information because the finish is quite interesting on that project as a 3D printed project. So that's really great. So I'll take one more text question because we have plenty, and then we'll jump back to the live questions. So Twinkle Catharia is asking, which material has the best longevity to sustain public spaces and is 3D printed? Pretty good question.
That's a great question. I mean, yeah, sand wasn't great because it would break, so you need very chunky elements. Metal is probably the best one because it's kind of fire resistant, it's kind of strong. Maybe a sort of a mixture of metal and sand would be quite interesting, like what you see outside, really. The concrete is nothing but that. So the problem with PLA and bioplastic, it's good. it's water resistant and so on, but there's no real flame retardant to prevent it from. I would say, okay, no, I have an answer. Earth is great. The only problem with Earth is obviously if there is like earthquake and so on. So Earth with some kind of tensile material like metal or some kind of straw, you know, earth and straw. Earth would be best.
Which is the project that WASP is working on, right?
And Yak. Yak is doing an amazing job at researching 3D printed architecture with Earth. It was wonderful, really.
I'm really looking forward to see what they do with that. Daniel Radin is up next on the live question. So host, please promote Daniel Radin to panelists, and Daniel's going to be with us in a minute. There's a bit of a lag from Zoom, but he should be with us any second now. Daniel, where are you joining us from?
Yeah. Actually, I'm from Lebanon.
Hello.
Great, Daniel. What is the question to Arthur?
My question is actually in the first of the live, he mentioned.
Daniel, we can barely hear you. Can you uncover your mic when you're talking and don't move the camera too much?
Okay. Is it good right now?
Yeah.
Yeah, it's good.
Okay. In the beginning, he mentioned that back in history, people could have many titles or many tasks. Like we could found someone who is an architect, at the same time he's an engineer, at the same time he's a mathematician, and there's an artist, and there's a painter. Now we are in the age of specialization, you know, that people like this doesn't exist anymore. So which one is best, you know, before or now?
Well, the future. I think the more curious, the more multidisciplinary, the more generalization, the better. I think because when you design something, and let's say you're a designer that doesn't know how to weld, right? You're going to design something that is not weld friendly, right? And so the welder will come, and either he has to really adapt to your design to really weld something because it's not weld friendly, or the designers know how to weld, and therefore you're not going to make his life hard, right? So I guess what I'm trying to say is the more you can learn as a designer, the better. The more you can learn, the more you can kind of go on a site and just like weld, the better. And I use weld, but it could be, you know, any other discipline. But I just think that then it creates a holistic approach to your designs.
Thank you.
Thank you so much for the answer, Arthur, and for Daniel for asking that question. We have a lot of questions, and I'm going to try to go through all of them. We have 23 questions, so I'm not sure we can do all of them. Okay, well, if you have another 15 minutes maybe, so we'll do them maybe really quickly. What is the source of your inspiration?
The source is, the source is, no, when I graduated, and I remember messaging, because I think I received a message from the dean of AA, and and I replied to him. I said, thank you for making me realize that everything can be inspiration, everything. And when I say this, it's not to be cliche, but I walk down the street, I see a flower, you know, the way the flower is, the way the leaf has developed veins, the way the colors are, related to some function. I guess I could answer nature in that sense, that it's everything, but it's pretty amazing to see how evolution, how, call it creation of these elements, how much it's sophisticated. Like, it blows my mind as an architect to understand nature, because it's way more complex than anything we could do. I mean, maybe not, maybe one day we could, but for now it's a very humbling experience. And I have millions of pictures of flowers and so on, you name it, on my picture.
I see them on your Instagram stories. That's for sure. And that's a source of inspiration for me as well when I see those photos. So thank you for posting them, Arthur. Great. So we'll jump to the next question on text. Someone with, I think a Chinese name, is asking, "Hi Arthur, do you manage producing and construction processes, so production and construction processes, or do you just offer the proposal, so the concept design?"
That's a very good question. We try, when we propose things, we try and design them so they would fit on our machine. Like, I say this because our machines are not huge. We have a WASP 3MT, which is about 1 meter by 1 meter. We have a laser cutter, roughly 2 meters and so on, and it can cut metal. So when we design something, we try and make it fit, because then obviously then we can not only suggest drawings to the client, but we can suggest the prototypes. And so by doing that, our contracts offer design and then plus if needed. And I always thought that it would be a way to just be involved in more places and to actually propose a more holistic approach to the design. And so we ended up proposing that in our contracts. Not always, obviously, when we do, I don't know, an airport or a tower, you can do that, but there's always something in the airport we can do.
Right, right. Great. We'll take one live question now. Prabhat Arora, host, please.
Hello.
Hi, can you hear me?
Yeah.
We can hear you, but you're not on video. Is that what you choose to do, or
Yeah.
if you want?
Yeah,
okay,
yeah. I'm sitting
fine.
in the dark, so.
He's in his pajamas.
That's okay.
All right. Congratulations, Arthur. It's such a great presentation. I love the kind of work you're doing, and I'm super inspired by nature myself. I love the infinite number of forms that nature has produced, including the human body. That's myself or you, we're like unique with unique racial and cultural identity.
Jump to the question, please, so that we can give room to others.
Yeah,
what is your question?
Way too complex. My question is, your projects, your Burning Man project seems very elitist and privileged because you get to build like at a place like Burning Man. I want you to explain how you scored the project or how you get to build at a place like Burning Man, as well as how we can bring this sort of community construction into real projects outside festivals like Burning Man.
Thank you, Prabhat. Where are you joining us from?
I'm from Southern India. I also graduated from the AA.
Great. Arthur, what's your answer?
Yeah, thanks, Prabhat. It's true. I mean, not everyone can go to Burning Man. That's why I'm quite attracted by this idea of the virtual reality. I know it's not the same, but if you have Windows now, you can download AltSpace and you can come and join me. Just add me as a friend on AltSpace. And it's a little bit further than social media in that you get to see a space in 3D. But it's sort of that little middle ground where anyone with a PC can actually see that space and experience it. So there's going to be an entire Burning Man there online, which I'm very excited of because I was kind of part of building some of it and so on, using tools like Unity and so on. So that was really cool with the team. And so that's one way to address the elitist aspect. The other thing is, how did I get in there? You'll be surprised. Like when I started working with Burning Man, I knew nothing about festival scene, or I was just a geek. Like I was teaching Grasshopper on Saturdays. I was just lucky that a friend of mine, very different from me, Toby, had a girlfriend who went to Burning Man and told me about this thing. And I guess my answer is like, if you're sort of, you meet people that don't come from your world. I think architects have a tendency to stay with architects. I think I've noticed that. It's very important to be open-minded to things that might be very different from your world. Like Burning Man, I felt like it's weird. What's that weird? They're in the dust like for a week and it's dirty but like I mentioned, I love other people's realities. So I just want to, like a little bit like you try a dish you don't like, right? But you see so many people liking it. So you're like, there must be something in that dish, right? Your cauliflower, I didn't like cauliflower. And then I start like eating it. I'm like, yeah, all right. And then tell me why you like it. Tell me why you like it. And so I think the more you kind of go out there, the more you'll see opportunities that may seem elitist because you haven't actually asked the people that were not so far away from you, like, do you know a cool place? Oh, I'm interested in bamboo. Do you know a cool place that do bamboo? Like, so go into places that there's this website called Meetup, for example. You can meet into, I don't know, all kinds of scenes, you know, and then get to ask them, tell them about what you do. But within architects, we're always like thinking, you know, maybe I'm not good enough, or he's better, or, but when you're out there, we're all great. Like, you know, you're great, Prabhat. Like, you know, when you talk to someone, everyone wants to be an architect in the non-architects world. And so it's a matter of going out there to the non-architects that have interesting opportunities and telling them, look, I know how to build with bamboo. Oh, you know, I can build you your whatever. So yeah, that's how it happened.
All right, we're going to try to breeze through another question. Thank you, Prabhat, for joining us, and stay online until the end of the session. Maybe you'll also hear some other answers of other questions that you may have had. One question from Sarah Home. She's asking, I'm sure that's not her full name, but Sarah, let's call her that. Can you repeat the name of the sugar material you mentioned earlier for the Saudi project, I'm assuming?
Yeah, so the Saudi project was done with sand and furan. Furan is F-U-R-A-N, furan resin. It's actually not such a great resin, like there are better resins out there. Someone told me off after the design article saying, oh, it's worse than concrete. And so I encourage you to look into resin binding of sand because there is way better stuff out there. I know the ETH is looking into it. But we use furan because that's what was at the place, you know, that we found in Saudi Arabia that can do it. For COS, we used PLA, which is polylactic acid, which is made of fermented sugar from sugar canes that come from, usually they come from places like Thailand and so on. I think the whole challenge with PLA is to find a PLA made from sugars that grow locally. So in a way, you also need to think beyond, like someone says it's a sustainable material. It's like, okay, it's sustainable because you're using renewable or like plants and crops, but where are your crops coming from? What happens after? Like, it's not biodegradable, it's compostable. Like, so all these questions were brewing and very important in the debate around these projects.
Yeah, 100%. Another thing is how big is the carbon footprint of shipping that material? So that could be something that's...
Yeah, it's terrible. Yeah.
Okay, one more text question and then we'll jump to Jack Young on live. So anonymous attendees asking, since parametric design involves creating multiple customized pieces, how sustainable is it really to execute parametric design?
That's interesting. I mean, any kind of design is made of pieces. I would say the purpose of parametric design is because you make one model that has everything in one go, you know, the parametric model. You can probably test it a little bit better against like the sort of standards. Like when we did Galaxia, I know it's kind of weird because we burnt it, but when we did it, we could measure the weight, we could make sure that the amount of screw was the bare minimum essential, you know? I think the overall weight of Galaxia, given the 3,000 meters square, was like really small. Same with COS. I think the weight was the same as foam. In terms of ratio. So you can really minimize the amount of materials. And so I think that's as sustainable as it gets, right? How to build with less.
Yeah, so Sarah's saying, her name is Sarah Jane. We had dinner in the, okay, so that's, oh, so she's a friend and she joined the conversation. Thank you, Sarah, for asking the question. It's a great question. And I actually had the same question in mind as well. So thank you, Arthur, for answering it. Let's go to Jack Young live now.
He's back.
Is that the same person that we had at the beginning?
Oh, he's gone.
I think it takes a couple of seconds for him to go on video, unless he decided to.
I think it's probably because it's the same that asked the first question.
It's the same person.
Yeah.
Okay, so my bad. Let's go back to some of the, I'm going to kind of skip through some of them, but Ghanem Yunus is asking, how accurate was Karamba 3D in predicting real structural behaviors while you're building your works? Thanks.
Very interesting. Pretty accurate. There's a specific moment that I remember where we removed the scaffolding of Galaxia And we were taking bets in the team as to how much it would go down, the whole thing. So there was a scaffolding in the middle, 100 tons of material on top. We have like cranks, and there's like 20 people, one crank each. We're standing below 100 tons, one of those scary moments. And we went down, and I think it was about twice the prediction, but I think RIBA planned like 3 centimeters, and it was 6 centimeters of deflection. It's pretty amazing, to be honest. And it's mostly due to us, not Caramba. Like, it's mostly due to human errors, because when you think of the accumulated tolerance and issues, I mean, the whole thing was built with ratchet straps and like volunteers that are unskilled workers. So I would say that's a pretty good testimony to the tool, actually. And to the amazing engineer, obviously, format engineers. Yeah.
Definitely. And you would only know when you build it, is kind of the short answer as well, right? Jack is upset. I'm not Jack. He wants to go live. So let's put Jack Young back live. I don't think it's the same person. I think we made a mistake there. So Jack is with us live. Okay, no, so that's not Jack.
Why does it say?
What's your real name and where are you joining us from, Jack Young?
My name is Annie Locke. I'm joining from Stockholm.
Great.
I have no idea why it says Jack Young.
It's fine.
Anyways, so my question for you, Arthur, is for those who are coming out of university and aspiring to start your own practice or join a practice such as yours, how do you balance the digital fabrication research in architectural design, that exploratory part that you don't know where it's going to go or necessarily turn a profit or something that you can sell to a client, and then the more, well, less fun, I guess, so to speak, of the financial constraints and running a business?
Wow. Thank you, Annie. Annie was also part of the Galaxia building crew. Amazing, Annie Locke. It's hard to give an all-covering answer. I would say that starting very small and staying relatively small, not wanting to grow in the sense, I mean, a lot of time, you know, like I was wearing a suit, I was in my bedroom, I thought, okay, by wearing a suit, I'll look a little bit bigger than what we actually are. And, you know, obviously everyone starts with teams, but the more I realized, the more I guess we actually kind of grow, the more I realized the freedom I had then. And it's a blessing to be by yourself, or having the freedom to kind of go experiment. You know, all the students are so lucky in that sense. There are blessed years where you're by yourself in front of a laser and you're just playing. What's hard is the self-discipline, or, you know, to actually be willing to explore and to play, which, you know, I was just having so much fun. I mean, to be honest, yes, I wrote business plans. Yes, I raised funds because I was reading a lot of entrepreneurial books. You know, the first book I read was like Losing My Virginity by Richard Branson, and so on. Then I read all of the Silicon Valley books or whatever, because I wanted to learn how to raise funds. But most importantly, it wasn't necessarily about doing a company. It's just like, I'm having so much fun. How, like, are other people, like, is that a way to make a business? And actually, I think it is. I think excitement is contagious. And I think, like, if you do something that's very exciting and you communicate it out to the world, people get excited too. And then suddenly people will sort of message you, and you'll see opportunities out there, whether it's someone hiring you, or it's someone wanting to collaborate with you, or it's an actual kind of private client, a non-architect's client. We're so lucky now that there is Instagram, that there is Facebook, that you can share your excitement and your talent and with the entire world, like, without having to have an amplifier or a curator selecting you. We're all in a way on equal ground in terms of the way we kind of share things now. I know some people don't want to share everything, but when you see it from the positive light, like, if you have exciting stuff, and I know that you're surrounded by, you know, very exciting stuff, and Annie, like, I just feel like, and maybe I'm just too naive, but I feel like if you're willing to take that risk, if you're willing to explore and share this exploration in in a very truthful way, it will come. Like, and we're often surprised by where it comes from. And I mentioned Kickstarter and these videos where we raise funds, and I know you did it too. Like people give, and you create communities around what you like, and you're part of communities, and people want to help. I remember helping this amazing guys in London, two guys that were wanting to do something for their local mosque, actually. And they had this idea of using Islamic patterns, and they did a giant thing with mirrors, laser cut mirrors. And that was their community, right? And everyone wanted to help them because they wanted to bring something to that community. And so they ended up building this amazing thing, and they raised the funds themselves. And so if you have a vision like this, write it down on paper, write down your ideas, write a spreadsheet of how much you need, and get out there, email people with these ideas, and who knows, it sort of materializes itself.
That's great. Thank you again for joining
Jack.
us, Jack. And,
Hi, Jack.
And greetings to Stockholm. So, Arthur, we have 19 more questions, and we're already 30 minutes into. Do you want to do it? Okay. Well, it's up to you. I mean, you're the one who's spending, graciously spending their time with us. So
it's a pleasure.
Let's do maybe 10 more minutes of questions.
Yeah,
we'll try to
let's
answer
go to
them
Jack Young.
Okay, Jack Young has already had his or her turn. But anonymous attendee asks, any advice for fresh graduate architects who want to start out and get involved in developing architecture informed by this kind of innovative digital fabrication?
That was Annie Locke's question, right?
It was the same question, so that we answered already. Harsh Desai is saying, can I know who funds these projects because it looks expensive to make such complex structure?
Yeah. So it's either a lot of people giving small amounts or one guy giving a big amount. Like, what I mean by that is it depends on which project. A lot of the projects didn't cost much more than 40,000 pounds. And in that sense, we sold a lot of t-shirts. T-shirts, stickers, you name it. Like, you find pendants. You make pendants, badges. And you'd be surprised how much you can raise by doing that. So that's, Tangential Dreams is probably, I would say, 60, 80 people. And then Galaxia was a lot of that, obviously, to reach a certain amount. I think we raised about 150,000 with that sort of stuff. Mm-hmm. And then people, we did what's called donor dinners. So anyone that was from that community that was sort of able, we would contact them and we would kind of suggest that we would do a presentation, and they'd bring their checkbooks, and if they like it, it's very common in politics, but not in architecture for some reason. Why not? I mean, people give, like, if they like something, they give. And so, just make a dinner with the people around you. It doesn't have to be, wealthy people. It's just people that you think will believe in your ideas. I'd come, like, invite me to your dinner. And, and then at the end, if we're convinced, we help. I mean, that's what raising funds is, whether it's for a project or for a company. So we were lucky to have, very wealthy people also give us also big checks, which happened through these dinners. Or we also organized a party. We rented a venue, we organized a party, and then asked DJs if they wanted to give their time. And they did, and we had an amazing DJ, Eduardo Castillo, who came and gave his time to, like,
wow.
So we raised $40,000 or something. So you see, it's just like event after event after thing after thing. It's not like, just don't give up. You can do it.
Nice. I like the spirit, Arthur. Okay, one more question from anonymous attendee. How do you maintain financial? I think you kind of answered that. How do you maintain financial stability in your practice? You kind of answered that through your answer just now, right?
Yeah, I mean, obviously you start, you start small, so the burden is small. Stay at home, like stay in your bedroom, like be as cheap as you can, because then anything that comes in, is survival. Eat sardines or whatever can make you survive for a while. And then as you grow, obviously your credentials grow, so your fees grow. But don't expect to have the same fees as a big architect from the start. Like you're gonna have to slash your prices, and you're gonna have to take a bit of a bet on yourself.
Yeah, that's a great answer. I believe Mayur Mystery asked 2 questions already, so we will kind of skip the people that asked too many questions. Do you think, or I think it's
like
just
people. I was one of them.
Okay, fine. He's asking what was the formwork used in the project for Burning Man. I'm assuming. What is the formwork? There is no formwork, right? It was just hoisted into place.
Yeah, but there was this giant scaffolding in the middle, which was actually engineered by a scaffold engineer. I didn't know they existed, and was designed by someone who designed the scaffolding, because it's something that I had no clue on. Like, the whole thing otherwise was sort of self-forming through the origami shapes. You know, module after module into these bananas, which you know. Annie, who was there, helped me do a paper model of the whole thing,
nice.
For example. Yeah.
Amazing. And if it wasn't for the spirit of collaboration, those people that kind of find their way to you, you know, most of the time, a lot of your projects wouldn't even see the light of day. Exactly. At least I would speak for myself.
Yeah.
Mayur asked a 3rd question. Please refrain from asking too many questions so that we can get to all of them. Mayur's question is, can you elaborate on the type of hinge used for folding? I think he was referring to the ratchet.
The ratchet straps.
Kind of, the ratchet straps.
Yeah, it's interesting because I think we needed a resistance of like, I don't know, something crazy like for each of them. I don't want to say, I think 40 tons of resistance. Sorry, I don't quote me on that, but we needed some crazy amounts. And I looked around and the only ones we could find was these sort of pink looking or orange looking ratchet straps. And I was like, that's going to be pretty visible. But at the same time, I was just thinking, wow, it's so much easier than the other solution. And the other solution was to drill a bolt, like a hole, through the entire connection, like in diagonal, cross bolts, not intersecting on like 4 pieces of timber in a row. Mental for unskilled workers that come as volunteers. You can't ask for them to do that. And so I'm like, you know, in that spirit, well, you know, F it. Like, let's do some ratchet straps. They're a little bit funny looking, but it's Burning Man. And it actually celebrates the fact that this project is about the people that build it and the educational nature of the project. So in that sense, maybe it's okay to celebrate imperfection, you know? But I can tell you people like at Burning Man saying like, what the hell, what kind of architects put ratchet strap in their project?
They're kind of like industrial grade zip ties, if I understand correctly.
Yeah, exactly.
And we architects love zip ties.
We love zip tie. Yeah.
Ghanem Yunus is asking, where do you see parametric design in the next 5 to 10 years?
I could see the computer doing a little bit more effort in that sense, that you're going to have the model, then you have what we call the genetic algorithms, you know, that play with the model until it meets a certain fitness criteria, and it plots these results onto different objectives. I'm sure you do a workshop on that, but say things like Octopus, they plot the solutions, and with VR, I hope you'll be able to like swim in all your solutions and sort of pick the ones that you want to. So in a way, I see it as much more generative in that sense. It generates a lot of solutions for you. And with VR, you'll be choosing them by just seeing them and inhabiting them. So remember the analogy with a gardener, you'll be sort of gardening all the possibility with the client, and you'll have site meeting, you know, multi-objective site meetings with your client.
Yeah.
I guess that's how I see it. Yeah.
Great. Jonah Klinghoffer is asking, thank you very much for showing these beautiful designs. I always love to see parametrically realized projects. Grasshopper is an extremely powerful tool that allows one to easily tweak parameters and create unique and unthinkable shapes, which would be nearly impossible to be modeled manually. I'm curious to what extent you think parametric design is less design-oriented and more experimentally or / unintentionally generated through the software's intelligence, or vice versa. Do you disagree or do you agree?
Yeah, yeah. I mean, you know, it's really hard to give a one answer fits all, because sometimes there is an idea that comes to our brain. Of course, I mean, the ideas are still there, like visions are still there, but sometimes you're kind of just playing, and then there's this cool thing that happens, and you're like, that's cool, you know, and then you work, like you say, Riyad, you work with a team. So sometimes other people play with their with the tool, with the material, with the wood, with the laser cutter, and then when everything starts showing up in the office, like there's so many kind of interesting things that could happen between, you know, some experimental 3D printing technique and a piece of laser cut wood that someone laser cut in a weird, strange way, and then you look around, and that's why maybe physical space is still very important, like the idea of offices, because when I'm sitting down and I'm seeing like this experiment and that experiment, and you kind of make association, you know. I feel like the architect is like an associator. He makes associations, and then the new thing happens from a series of these associations. But I don't think we invent anything. I think we just kind of put things together in new ways. So in that sense, no matter what the technique you use, no matter if it's parametric design encourages that, because it's literally associations. But even before that, you know, we were making these associations of things. Yeah.
So someone is saying Galaxia was arguably the most impressive temple built at the Burn. It was clearly also a huge learning experience for many involved. What are the key lessons you feel you may have learned from the project, whether for you, for your practice, or the community of the Burning Man organizers?
I mean, that's a very lovely and kind thing to say. I partly disagree. I think there were some really nice ones. There was one that I saw, which was like a pyramid made of like CNC cut pieces of wood, and they didn't use any fasteners, so no metal. And so it was
Japanese joinery.
Like incredible, by Greg Fleischman. That was the first one I saw, and I can only dream that not using fastener for Galaxia would have been incredible. So in a way, it wasn't as clever in a sense that we couldn't. But what I learned is. I think maybe it's kind of weird to say, but maybe I should listen even more to my team. I think people had frustrations, and I wish I had an even bigger open ear. It's hard to listen to people at the same time do things, and you know, and I was relatively young, and it's not. I didn't want to upset people, but of course you upset some people along the way, because you have to take decisions that are not the compromise that everyone wants, right? And sometimes you just got to keep that coherence and like leadership in that sense. And so sometimes you upset people. And looking back, I could have avoided some of these upsets. And so for the next lesson, I try and minimize that by, of course, involving the team on an earlier level in the discussions, and really keep an open ear at any. I think the more you're open ear, the more you're like a sponge to your team, to the people around you, the better, because the more they feel involved and the more they feel respected in their contribution. And so I think that's something I'm learning even more. I mean, one could say, oh, well, you're already doing it, but I feel like we never do it enough. And I think that's really hard. I mean, it's you know, yeah.
For sure, giving autonomy to your team is a lot more rewarding, and also gives them a sense of responsibility, and you know, they feel like they want to develop also their skills a bit more, which is beneficial for everybody.
Yeah.
Solen Bish is asking, in the realm of conventional education, when it comes to parametric design, I often come across the misconception that algorithms are automats, and when used in fields such as architecture, they are seen as a tantamount to this diminution of creativity and imagination. What would you say to refute this?
I guess when you kind of go to the park and you see a tree, right? Like you surely feel the beauty of that, right? Like you surely see the trunk and the veins and the amazing roots and the self-organizing thing. Now, you know, did it dissolve anyone's creativity? You know, I just ask because I ask myself, like, you know, maybe there is a creator, you know, I'm open, very open-minded to that. Maybe there is none, like, but one thing for sure is beautiful, right? And I don't really need to think of the dissolution of creativity because I know that it's creative, right? Like you know, it's creative, right? When you see the bees, when you watch David Attenborough's documentary, you know, somewhere in there is creativity, right? Mm-hmm. And so if you can just reach 1% of that, and if the computers can help us make our cities as pure and harmonious as that, then, you know, to hell with what we used to think was creativity, right? Like, mm-hmm. I don't know. I think the risk is doing it without a sense of understanding. Like, the risk is being a slave to it. Like, that's why you need to learn code. That's why you need to register to this live academy.
Yeah, definitely. Thank you for the free ad, Arthur. But I do agree with you. I think all of these tools are extensions to our palette of tools that we can use. And without the right mindset, without the right process behind the design, anybody could use a tool and come up with a design that's not so great.
Yeah.
So having that extension is definitely useful. It doesn't solve any problems of a bad designer, though. Mm. How does the connection, so that's this question from Anaga Patil. How does the connections of the 3D printed modules work? Are they bolted together on top of each other? If yes, how do you manage to hide these connections?
I don't hide them. And it's often just zip ties. No, yeah, I mean, I guess I don't, yeah, I don't. I really love soft joints. Like, I love the idea that, you know, it's not, a bolted connection are great, but they don't allow for a lot of tolerance or a lot of movement. You know, our joints, our connection in our bodies are soft, right? Like there's ligaments, there's cable ties, kind of. So, I mean, of course, you want to design beautiful joints, but at the same time, that's probably the most expensive part, and it's the part that lets you down, right? So maybe I would love one day, and please the audience and Riyadh, like, to do, like, you know, these soft lashing joints, bamboo joints, maybe to think of things like ratchet straps, but in a more elegant way, I guess.
Yeah.
That would be amazing. I mean,
that's a nice idea. Shirag Agarwal is asking, how can we volunteer for Burning Man projects?
So email me. Email me, you know, Arthur at Mamou-Mani.com. I'm not saying that I'm going to reply to everyone, but I have a list of potential volunteer for next year, and I'll ask you questions, and probably we'll see, you know, like, but I have a list of people that for next year. And yeah, feel free. That's yeah.
I'm probably going to sign up, Arthur, after I saw that presentation. I'm not going to lie. It's very you know, tempting to do so. Jenna Shahata is asking, I'm very eager to see these creative and eco-friendly parametric designs implemented in the creation of refugee camps. I believe that this will be a very fun way to explore, especially with the use of local materials.
That would be amazing. Like, I think you're right. Like, 3D printing with Earth at the Yak, they were doing refugee camps. I love when people take that risk, because that's, you know, I talk about the risk of entrepreneurship. I think the risk of doing charitable work is so noble, you know, it's so noble to take that risk. So amazing. Like, if you can do it, you know, let me know. I hope I can help. But yes, I think it's, and especially people like Buckminster Fuller, you know, like, or Jean Prouvé, or they all came up with solutions that would be disassemblable, assemblable, that would work with refugee shelters. And that's also why I love Burning Man, in a sense that we learn about assembling and disassembling structures and having convenient structures that indeed end up often, actually, it's a surprise, but the Hexayurt movement, the open source Hexayurt movement that started at Burning Man, helped produce community shelters for refugees. And there's a lot of initiative like this. Greg Fleischman, who did the temple, also did that.
That's great. Abdullah Zarqa asks, how important is the technical knowledge of a software compared to the knowledge of what is being done and therefore on the overall aspects. I often think that knowledge of a program becomes a limit, but I know that it shouldn't be that way. I think you kind of answered that question before, right? I think with the previous question in a way.
Yeah, I think you, but I hear you. I hear that person's question. Like the issue when you do software and you start learning software, you do cool shapes, right? Mostly, I mean, most of the time it's linked to the act of creating things that are not necessarily informed by knowledge of building, because often you learn software before you learn being on site. And some of the best guys, you know, we had a Galaxia, you know, you saw Jack and Annie. They're often people that did an internship in a carpentry workshop, or like they went in a metal worker's place. And a lot of the people I have in the company are people that did that. They went and did a summer at a carpenter's shop. And it's so amazing when you see on a CV, you know, I built boat. Suddenly you scroll through the portfolio and you see like a boat.
Right.
You know, I think it's important.
Anonymous attendee is saying, and sorry, Arthur, you brought this to yourself, but we have 10 more questions. Now I cannot stop anymore because we're almost there. We got also 10 more minutes, so keep it one answer per.
Perfect. I'll put the timer.
1 minute. Yeah. Hi, thank you for your interesting lecture. I have a question about the CNC-milling textile surface. How did you apply your 3D model onto the textile, and did you use 3D printing on the fabric? Nice question.
Nice questions. It wasn't the age at the time. It was in 2013, so we didn't have 3D printers that were big enough, or we weren't doing any of the robotic stuff. But I think that's a really good idea you have, whoever asked the question. So we basically sort of, the first prototype that I showed you was kangaroo lead, and then unfolded on kangaroo, then you plot the points. And then you take we had a spreadsheet with all the points of the unfolded elements. And we were just, you know, a colleague was screaming the distances from the spreadsheet and with a red pen marking, and then tie them into the bunch. And so that's how we linked the 3D through a spreadsheet and through red dots. So that was experimental, but we needed a huge warehouse, which we were lucky to find. And yeah.
That was one of your first projects, one of your, if I remember correctly.
Yeah.
In many projects, so Anurag Pandey, sorry, I'm butchering everyone's name, but we have such a diverse, multinational, international audience that I have to kind of train myself with names from different countries. But Anurag Pandey, I think I said that right. In many projects, architects said that his or her project helped the community, but in reality, it's the opposite. But your projects inspired me how projects related with community, and I wanted to ask that during this pandemic time, we were more focused on social distancing. How do future projects ideology change that? So he's trying to ask, in this pandemic time, we are focused on social, or we have this sort of restraint of social distancing. How can we help our societies through our projects in these current times?
That's really nice.
Yeah.
I saw one is something beautiful happened. Like we were printing the masks. Like everyone who had a Fab Lab started printing masks for the pandemic. Yeah, and we didn't know how we were going to finance that or anything. We were just kind of doing it because we wanted to help.
And by the way, Alvin Wang is giving a lecture at the end of this semester. So he would be also presenting, I think, some of his PPE masks that he did with.
Amazing! That's amazing. I mean, it was an amazing movement, like, and so beautiful to see everyone being kind of helpful in that sense. And then I thought, well, it's kind of nice. We just did it, and then the hospitals just sort of asked us, and then some nice people just donated some money, and I was just like, wow, this is ultimate sort of. You know, entrepreneurial, communal effort, civic responsibility, it's everything that I love. And so I started emailing the council. I was like, oh, okay, Tower Hamlet Council in London. And I was, do you have like something, a department that deals with homeless people? Like maybe, you know, we have a laser cutter, maybe, I don't know, like we have a 3D printer, maybe we can build some shelters. And I sent that email to the Tower Hamlet Council, and they replied, and they have a homeless department, and so you know, it's kind of nice to self-initiate help. Someone talked about refugee shelters, like you feel free to email your councils, your governments. Governments are made from people, right? So like local councils, and just say, look, I have these skills, you know, or this and that, so I can help. And you know, why not? Why not bring what we did at Burning Man to the cities? Why not build temples in places or places where people can write things or where communication can happen? You know, architecture can be a place of dialogue, just like this platform. You know, you can come up with ideas of places where people can share thoughts and ideas and suggest.
Just like your VR space as well.
Yeah. Also, that's amazing. Like, if you can afford a $400 Oculus, it's probably, at the time when I bought the $400 RepRap, I think we are now at the time, same time, like, get one and invest into learning Unity, invest into learning Twinmotion, Unreal Engine, because this is the future. And I really believe that I think we are at a key moment in our profession where we're going to switch to VR, and this will be the ultimate environmental device because you're building without building.
Right. And speaking of VR, Anuj Modi is asking, do you think that concerts like Travis Scott's on Fortnite will change how we perceive events and will change the course of connecting millions of people at the same time? Or is this a temporary kind of trend?
No, they call it the metaverse. It's the idea that the internet will just be a world in which we physically interact, no longer on a screen with like text and hyperlink, but with objects that we actually touch. I'm sure that once you put your Oculus or any kind of device on your head, you will see the power of the reality, the immersion. It's phenomenal. Like, and I had a site meeting, you know, with a client in Catharsis, and he was like, "This is the first time I feel the scale of that thing." And I was like, "Oh, that's interesting," because you see it in relation to your body, whereas when you're on Rhino, you don't do that, right?
Yeah.
So it's not definitely not a trend. I think it's going to change everything.
Alawi Ali is asking, how long do these types of projects take from planning to execution?
6 months.
Depends on the project, but yeah.
Well, all of them took around 6 months, like half a year. I think from Galaxia to Conifera they seem to be like, we operate in modes of 6 months. For some reason, I don't know, I'm giving you that number because it seems to be our average, which is nice. It's faster than architecture. In a sense, architecture building-ish, which seems to be more 2 years kind of scales. So I kind of like it. It's quite rewarding. It's faster.
Okay. Someone is saying, anonymous attendee is saying, "Salut, Monsieur Arthur. How are you? How do you think this pandemic will affect the way we architects design spaces?"
I think you probably, you know, I don't know if it's the same in your places, but in London or here in Paris, the air is incredibly pure. The streets have not that many cars. People spend time in the park because they want to breathe, you know, and it's pretty amazing to experience a city not at 100% capacity, you know, like if it was a machine, it's running at like maybe 20%, right? Right. And it's pretty amazing to experience that. And I'm sure a lot of people will remember now as a sort of objective for a city that is much nicer to live in. I mean, I was unlucky to get the COVID, but I luckily kind of survived it. So
you caught the virus?
Yeah. I caught it for 3 weeks with my wife. Yeah, it was horrible. Wow. Like the one thing that's really horrible is the difficulty to breathe. Like you're like, you're trying to breathe and air is like thick, like, and it's like, oh my goodness, like I didn't realize how, you know, it's like this automatic thing you do all the time, you breathe. And when you can't, you're like, wow, like we're so lucky, like oxygen, all these things, like. And so I think we're going to treat, and I hope we're going to treat the environment with more respect, and we're going to realize our impact, because the positive impact was obvious when we stopped doing these things, right? So I have amazing clients that come with amazingly creative solutions, you know, building places where you grow your own food, or places where, you know, half of the space is with plants, or like you come up with like solution where you give back, you don't just take. So you create a home where you know that you will give back to the city with nature. You will have bees or pollination happening on the roof. Like, and I tell my clients, I say, oh, we should have bees, or and then they get so excited because they agree. You know, everyone will, I think, agree now that we need to make an effort, and we not just to be like eco or, you know, leftist or whatever. My parents were actually very keen to bring together the capitalists, the hardcore capitalists, with the environmentalists, you know. And that's because they thought that's the only solution. I mean, we're not going to change society and make it communist. Obviously not. It didn't work. Right? So we need to find middle grounds, and we need to respect each other and find like pragmatic solutions. And that's what all the projects were about. Like the Saudi project was about finding local material. The Conifera project was about working with H&M owned company on things that can be composted. No one knew what composting was at the time. Like, I went to the meeting, no one knew, you know, and people don't know. They need to be shown. And so that's how the world is changing, I think. Like, we need to know that we have the power to do these little things there, minute changes to help people understand.
Well, congratulations, and we're very happy that you and your wife had recovered from COVID-19. I had no idea, and you're very brave to actually say this live in front of all this audience. So thank you so much, Arthur, for this incredible presentation. I myself have enjoyed it so much, and clearly from the never-ending questions that we're seeing here live, people have enjoyed it as well. But I have to end it now. It's 8 p.m. in Dubai time. Arthur is logged in from Paris, so thanks again for this amazing presentation. And to the audience, I have one thing to say, which is try to sign up for as many of these sessions as possible. Our aim is to spread knowledge and to connect these incredible people together. So join us on the next session. The next class would be given by Alessandro Zamparelli on Blender. Arthur, thanks again for this wonderful session, and
thank you.
Stay safe wherever you may be.
Thank you. Thank you, Riyad. Thank you, everyone. I really enjoyed this.